Hi, Deirdre Macnamara here again. This is the second half of the algebra slide set, and we're looking specifically at algebra in action, and the example we're using is menu costing and looking at food costs, etc. But that's only one example of how you might use algebra in industry. Okay, one example might be when you're moving from one measurement type to another. You're going from pounds and ounces and you need to move over to kilograms and grams, or vice versa. You're converting from one measurement to another, usually imperial to metric. Most of our recipes nowadays will be done in metric, and usually you're moving across. Sometimes the recipe might call for grams, but you're buying in as a kilogram and you need to go from kilograms across into grams. So that's within the metric system. One example, a recipe requires 300 grams of icing sugar, but you've been told that a 1 pound bag of icing sugar costs 1.34. So how much is it going to be for 300 grams? Okay, so this is the metric system. Grams is metric, pounds is imperial. So you need to work out how you're going to cost the 300 grams of icing sugar. Your solution then would be to move from pounds across to grams and then do your costing once you have it in grams and multiply by 300. Another example will be a recipe requires 500 grams of icing sugar, but you've been told that a kilogram bag of icing sugar costs 1.98. And the solution will be to move the kilograms across to grams and then do your costing. Okay, so here's a list of some of the conversions. As far as I'm concerned, life's too short. You shouldn't have to know these off by heart. You'll be told, for example, that 1 pound of something is the same as 453.59 grams, or 0.45359 of a kilogram. 1 ounce is 28.3495 grams. 1 pint, and here it is in litres, fluid ounces to millilitres, litres across to pints. The one that you should probably know is that there are 1,000 grams in every kilogram. That's something you should know. Okay, and 1,000 millilitres in a litre. The old imperial method, and again we will provide this in the exam. There are 16 ounces in every pound. And here, down here at the bottom of the slide, you can see I've just put a little chart for you to let you know that you will be able to see that within your exam environment. Okay, so for example, if you've got 5 pounds 2 ounces and you want to go to metric, okay, step number 1. At the moment, we've got pounds and ounces all together. Okay, so the first thing we're going to do is we're going to bring the pounds over to ounces, and we know that in every pound there are 16 ounces. Okay, so 5 pounds 2 ounces is 5, which is 16 ounces. 5 multiplied by 16 plus the 2 here. Okay, so 5 multiplied by 16 is 80 plus the 2 ounces. So there are 82 ounces is the same as 5 pounds 2 ounces. Okay, so that's step number 1. You start off with pounds and ounces and bring it all to ounces. We now have 82 ounces. That's the same as 5 pounds 2 ounces. Okay, step number 2, convert across to grams. And in the chart down here, it tells us that 1 ounce is the same as 28.3495 grams. So all we do is we multiply the 82 by this thing here. We looked up the chart, we multiplied it by 28.3495 on your calculator, and we know that 5 pounds 2 ounces is the same as 2,324.7 grams. Okay, so now we've converted from pounds and ounces across into grams. Another example here, 3 pounds 4 ounces. We've got pounds, we're going to convert that over to ounces, and then we'll add on these ounces here. Okay, so 16 ounces in a pound. Okay, so 3 multiplied by 16 plus the 4 we had here, so that's 48 plus 4, which is 52 ounces. So 3 pounds 4 ounces is the same as 52 ounces. And then we go down to our chart and we know that 1 ounce is 28.3495 grams, and we multiply it out. So 52 multiplied by 28.3495 on your calculator, and you'll get 1474.17 grams. So 3 pounds 4 ounces is the same as 1474.17. Now, here are some examples you can work on. I think you should hit the pause button on your video and actually try them out. Make sure that you're getting the right answers. And here are the answers. Okay, we're going to begin by doing some simple costings now. I've chosen the simplest recipe I could think of, and that's apple juice. So how much did it cost to make that glass of apple juice? Okay, we know from our suppliers we can buy 6 apples for 60 cents. What is the cost of 1 apple? Okay, the recipe uses 5 apples. We don't actually, we're going to have 1 spare here. So how much for 5 apples? It makes 2 glasses, our recipe. It doesn't just make 1 glass, it actually makes 2 glasses of apple juice. So how much to make the whole recipe? And then how much does it cost for 1 single glass? And this method is a very simple method, and you'll use it for much more complicated costings as well, but it's exactly the same. It's just a few more lines in the calculations, and you repeat the same thing again and again. Okay, so let's work through it. 6 apples cost 60 cents. We've done this previously in algebra, so 6a equals 60 cents. We want to get rid of the 6 here because we just want a single a. So here, 6 divided by 6 will give us 1. We have to do the same on the other side of the equals. So 60 cents divided by 6, and we get 1a, or just a by itself, is 10 cents. So a single apple cost us 10 cents. But the recipe uses 5 apples. Okay, so we're going to multiply this by 5, so we get 1a multiplied by 5, and then multiply this